All right, so Quadratics Day 6. I know today's the day you've all been anxiously awaiting, where we actually start solving quadratics. You're going to learn several different methods. Today I will specifically tell you what method to use and do some examples. And then tomorrow, or the next day we do Day 7 notes, I will show you one more method, and then basically you get your choice of how to solve. So it's important that you recognize the different forms. All right, so these examples we're going to solve by factoring. So this is the case where the a value is equal to 1, so it's easy to factor. You always have to have these set equal to 0. Always. Okay, so we need to multiply to negative 15 and add to negative 2. And those two numbers are going to be 5 and 3. And the 5 has to be negative. So this factors to x minus 5 and x plus 3 equals 0. So hopefully we all remember when you multiply two numbers, if one of them is 0, you always get 0. So it's called the zero product property of quadratics. So when solving, once you get it factored, if x minus 5 equals 0, then the whole thing's equal to 0, so x equals 5. And then my other factor, x plus 3 equals 0, so x equals negative 3. So both of those values will work. Typically, when you're solving a quadratic, you should get two solutions. Okay, so this one is set up not equal to 0, so we need to move that 5 over to the left-hand side. So we have 2x squared plus 9x minus 5 equals 0. Okay, so there's no greatest common factor. Always look for that first. So we're going to go through our M method. So we're going to multiply 2x squared and negative 5, and we're going to get negative 10x squared. Going through the factoring pretty fast now. So then we look for the two numbers to multiply and get negative 10x squared and add and get positive 9. So that has to be a 10x and a 9x. Sorry, a 10x and a 1x. And in order to get a negative, one of them has to be negative. So to get the positive 9, I need my negative 1 there. So then I bring down my n terms. So 2x squared plus 10x minus 1x minus 5 equals 0. So I'm going to factor by grouping because I have 4 terms. So here I can pull out a 2x. So I get 2x times x plus 5. And I need to make sure to get x plus 5 from my second group. So in order to do that, I have to pull out a negative 1. So I'm going to have a minus 1 times x plus 5 equals 0. So then if I finish my factoring, I have x plus 5 times 2x minus 1 equals 0. Set each of my factors equal to 0. This is an easy one. X has to be negative 5. And here, I have 2x minus 1 equals 0. 2x equals 1. X has to be 1/2. So two solutions. So now this one's a little bit different because I'm missing that constant term. So it's already equal to 0, so I have a greatest common factor of 3x. So if I pull a 3x out of this one, 6x squared divided by 3x is 2x. And negative 3x divided by itself is minus 1 equals 0. So I can apply my zero product property. So here x equals 0. And x equals, if I add 1 and divide by 2, I get x equals positive 1/2. So the main thing you need to understand about this is you've got to recognize the quadratic that's given to you and use the easiest way possible to solve. All right, so these examples are another method called using square roots. So hopefully you'll kind of see that the b value is missing in these first two examples and this third example, and then this one is given to you in a whole different form. So we'll approach that one a little bit differently. Okay, so in this case, since that b value is missing the bx value, if it's equal to 0, you can just move that 32 over and solve. So if I move the 2x squared and move the 32 over, it becomes a positive 32. I can divide both sides by negative 2 or positive 2 and get x squared equals 16. And then hopefully you remember to solve for an x squared. You take the square roots of both sides. You've got to remember that plus minus. So you get x equals plus or minus 4. So two solutions, positive 4 and negative 4. Okay, so this one is in the same form, except my numbers aren't going to divide nicely. So I'm going to go ahead, I'm still missing that bx term. So 3x equals 5. Move that 5 over. So divide by 3. So x squared equals 5 over 3. And you're going to learn in Algebra 2 that fractions are better than decimals 99% of the time. So now I need to take the square root of both sides. Got to remember the positive negative to get my two solutions. And I get the square root of 5/3. So that's kind of a yucky answer. So we need to do something called rationalizing the denominator. So here I'm going to show you how to do that. It's not too bad of a process. So plus minus, I'm going to put the square root of 5 and the square root of 3 using my properties of radicals. So in order to get rid of that denominator of square root of 3, I'm simply going to multiply by the square root of 3 over the square root of 3. So hopefully you remember your radical properties from Algebra 1 as well. So if I do that, I get plus or minus square root of 5 times the square root of 3 is the square root of 15. The square root of 3 times this itself is the square root of 9, which is 3. So I have now done the process of rationalizing the denominator, which basically means getting rid of the radical in the denominator. All right, so this one, well, if we just think about this one a little bit, x squared plus 6 equals 0. If I move that 6 over, x squared equals negative 6. And if you just use a little bit of common sense, when you square a number, no matter what it is, you always get a positive number or 0. You never get a negative number. So this problem has no real solution. Later on down the road, you're going to learn that you have what's called imaginary solutions. Okay, so this one, if you go ahead and set it equal to 0 and subtract that 15, you should see that it's going to be in vertex form. So in this case, this is probably the only situation where you don't want to make it equal to 0. So the easiest way to do this is divide both sides by 3. So I get x minus 4 squared equals 5. So then I can take the square root of both sides. So I get x minus 4 equals positive or negative. Don't forget that. Square root of 5. Then I can add 4. And I get 4 plus or minus the square root of 5. There are two solutions there, and they are both irrational real numbers, so non-repeating decimals. So that's the easiest way to solve something that's in this form. And on this next example, we're going to take this quadratic and we're going to do a method called completing the square, which will basically get you to the form of the problem we just did. All right, so completing the square is kind of a fun one. So we're going to make this into vertex form. So in order to do that, I have to turn this into a factorable trinomial. The 27 really has nothing to do with it whatsoever. Okay, so I'm going to move that 27 over to the other side. So I'm going to have x squared plus 10x equals negative 27. So I'm going to do the method called completing the square to make this what is called a perfect square factorable trinomial. So in order to do that, I'm going to add a number here to complete the square. I'll show you how to get it in a minute. Equals negative 27. So back in the day when you learned to solve equations, you know if you add something to the left side, you also have to add it to the right side. All right, so in this case, I'm going to have x squared plus 10x, and my box is equal to the b value, which in this case is 10, divided by 2 squared. Okay, so I'm going to have the boxes equal to 10 divided by 2 squared. So my box is equal to 25. So now I have x squared plus 10x plus 25 equals negative 2. So this is factorable now. So I need to multiply to 25 and add to 10. So those two numbers are 5 and 5. So I can keep factoring. This one will be x plus 5 times x plus 5 equals negative 2. So basically I have x plus 5 squared equals negative 2. And this is another situation that if I square anything, I should always get 0 or a positive number. So since this is equal to a negative number, I get no solution. So if I would have had a positive 4 over here, for instance, then I would have taken the square root of positive 4 and gotten plus or minus 2, and then subtracted 5 from both of those. So another situation with no solution. So I have one more here. Let's see what happens on this one. So this is going to be another tricky little case because I have a 3 here. So the first thing I want to do is move that 5 over. So I'm going to have 3x squared minus 12x equals negative 5. You can't complete the square unless you have a 1 sitting here. So this is kind of challenging. So the first thing I have to do is factor that 3 out. So I get x squared minus 4x. And I'm going to go ahead and add my box here because I'm going to have to complete the square on that trinomial. And I have a negative 5 plus a box. All right, so remember your box is equal to half a b squared. So negative 4 over 2 quantity squared. So my box is equal to negative 2 squared, which is 4. So inside here I put a 4. Now you've got to be careful because the box on the right side has to be the 3 times the 4. Since I distribute that 3 in there, this has to be a 12. So now I have 3 times something equals 7. So I have to multiply to positive 4 and add to negative 4. If I factor that trinomial. So that's going to be a negative 2 and a negative 2. So I have lost my train of thought here. I have x minus 2 times x minus 2. So I'm going to divide both sides by 3. And I have x minus 2 quantity squared equals 7/3. I'm going to take the square root of that. So x minus 2 equals plus or minus, and I'm going to go ahead and do the square root of 7 over the square root of 3. I need to rationalize that, so multiply by radical 3 over radical 3. So I get x minus 2 equals plus or minus 7 times 3 is 21 over, that should be a radical 3. Radical 3 times radical 3 is 3. And then I add 2 to both sides, so x equals 2 plus or minus the square root of 21 over 3. So that one worked out a little bit yucky as well, but it is a real number and it's called irrational. It would be a non-repeating, non-terminating decimal. All right, so you have a few to practice, and I've designated on this worksheet what method to use, which should help a little bit. Take a look at it, do what you can, and again, I'll be glad to help you and do some more examples tomorrow.